Hey everyone, welcome back to my channel EduVibe. Today we will start with the last topic of the matter and the chemical bonding. We're finally completing this unit. And today we're doing the last topic of this, and in the next lesson we'll do some practice questions. Then we are officially end with this unit. So today we're doing the last topic, which is intermolecular forces, which are the very important topic, and we get the theory questions from there. So the what are intermolecular forces we already done in the previous lesson. So if I told in the short that what is intermolecular forces, so intermolecular forces are the forces of attraction and the repulsion between the molecules. When to the attraction or the repulsion between the molecules, and that force which they attract to that molecules, so that are called the intermolecular forces. The molecules where do the force on the each other, attraction or the repulsion. So intermolecular forces are weaker than the covalent bonds. So always the intermolecular forces are very weaker than the covalent bonds, and the covalent bonds are also known as the intramolecular force. So if the words there is written intramolecular force, so this means there is a covalent bond we are talking about. So intermolecular forces are weaker than the covalent bond, which are the intermolecular forces. So we have a three types of forces. We have a three types of forces where we can see that which molecule has the like highest boiling point if we want to know. So we are calculate these. We are calculate the electrons. We calculate these by the three types of forces. The first one is the dipole-dipole force. So the dipole-dipole force is an attraction force and between the permanent dipoles in the adjacent polar molecules. When they are the adjacent polar molecules to each other like this, so in this attraction they have the positive, they have a negative, so they do the attraction. So that attraction when they do, so they are the adjacent polar molecules either side, and that when the attraction they do, so this means that this is a dipole-dipole. In this they have positive and the positive, so this positive do the repulsion. They don't bother, they don't have like dipole in that case. They have dipole in that case when they have a positive and negative and attract each other. So the more polar molecule has the stronger dipole-dipole force. If we have a much stronger dipole-dipole force, so that means we have a more polar molecule. To find out the dipole-dipole force, that how strong is this, you have to find their polar or the non-polar things. If there is a polar, so this means the dipole force is there. If it is non-polar, so this means it's not the dipole-dipole force in this. So the next of the force is the London force, or we can also say there's a London dispersion force. So if this results from a momentarily or induced dipoles due to the electron movement within the molecules. When we have the electron movement involved in anything, so we are talking about the London forces, which are London dispersion forces. They occur in all the substances. All the substances have that force. So when we do the questions, we will see that when we do the question, they don't have like, sometimes they don't have dipole-dipole force, sometimes they have another which we do the hydrogen bonding, but they have that London dispersion force. The short form we know this is LDF we talk about. So the strength of the London dispersion force we can calculate by the increased number of the electrons increase. If the electrons are increased of that particular molecular substance, this means that the strength of the London force is very increased. So to find out the strength of the London force increases, so we have to find the number of electrons they have. If that increase, then the London force also increases. And this is the symmetrical distribution of electrons. We have the symmetrical distribution of electrons, and we can see the instant dipole movement of that. We see the movement, the positive end goes out, and that positive end goes with negatives, and that they interact to each other. So this is atom 1, the negative, and this atom 2 has the positive, and they attract to each other. So this means they have the induced dipole movement. So induced word means that we have like some type of thing happen in that, in the positive or the negative manner. So the last force is not the force, like hydrogen bonding. So hydrogen bonding is very easy to see that if they have the hydrogen bonding or not. So occurs when a hydrogen atom is bound to a strongly electronegative atom with the lone pair of the electrons F01. So the hydrogen bonding occurs when any hydrogen atom is attached to the very high electronegativity atom. If any atom has a very high electronegativity and the hydrogen bond is connected to that, so this means that we have a hydrogen bonding. And we are with the lone pair. We also consider with the lone pairs of FON. FON means the fluorine, we have oxygen, and we have nitrogen. So if these three pair of lone pair of electrons have there in the hydrogen bonding too, so this means we have the hydrogen bonding in that atom. So as we see over there, we have hydrogen and they connect to the oxygen. So this means this is a hydrogen bond. And this also we have a nitrogen bond in this, we have fluorine bond in this, we have the carbon and the oxygen bond again in this. So this means they all are the examples for the hydrogen bonding. So that's how you can find the hydrogen bonding. So we have one example from here from that concept. It is how can we actually doing that questions when we get those. You basically get those questions like in direct response or in the MCQs. So what when we do, use the London force theory to predict which of these hydrocarbon has the highest boiling point. Methane, ethane, propane, and butane. And we have a formulas for this too. So basically we have to calculate the boiling points of that. And as I want to tell you one thing first, that if you want to find the boiling points, they basically tell you about that find out the boiling points more frequently. So to find the boiling points, so here's one trick to know this. We do that question later, but we find the trick first. So if you have like we have a highest boiling point and here we have the lowest boiling point. So we are go from highest to the lowest. So if we have some ionic molecule substances, so this means if we have an ionic one, so we have a highest boiling point. Then if we have the LDF force in that molecule substance, this is polar, this means it's a dipole, or they also have the hydrogen bonding in it. So if they have a both three of these, not the ionic one, if we have the both three of these, so this means also we have the highest boiling point, but lower than as compared to ionic bonds. If we have only LDF and the dipole, which is polar one, so this means we have the highest boiling point, but more like not very much high, but we have some boiling point of this. If we have the LDF and we have a most electron, like we have a highest number of electrons. So this means that again we have are closer to the lowest boiling point, but we have some boiling point, not the highest one, but we have like moderate one. And the last, if we have LDF and we have the least number of electrons, so this means we have a lowest boiling point in that case. So if you know this type of thing, this type of table, you have to know that if you know this, you can solve these questions, type of question easily when we're talking about the boiling points. So boiling point also frequently asked from this type of thing. So this everything you have to know, and let's use this technique to figure out how this question works in this. So we have the four molecules, we have a hydrocarbons in that case. So we have CH4, we have C2H6, which is ethane, then we have propane, and then we have a butane. So these are all are the hydrocarbon molecules. So first we have to find that they have a LDF or not. As I told you, all the elements have all the molecules are found, all the substances have some. Every time they have a LDF. So this means this has LDF, this is also LDF, LDF, and LDF. They all have LDF. If we talk about the dipole one, which is the polar one, so if we write the dipole, so in that case, they are not our polar ones. If we made the first one, we get C, we connected H over there, H over there, one H over there with that sign, and the dotted one H over there. I made the Vesper diagram, instant Vesper diagram with this, and I see that all the all the satellite atoms are the same. If they are the same, so this means this is non-polar. And if we consider all that four of them, we see that all that satellite atoms are equal. And they all made the tetrahedral or the triangle panel. They don't make the pyramidal, they don't make the band, which are the exceptions in that case. We have a polar in this. But in that case, we made some In that first one we made the triangular one, then we have to pyramid, and we have to find tetrahedral sometimes, and all of these didn't make anything which say there is a polar. So this means that these all four are not the polar one, they are the non-polars. So this means that we don't have the dipole-dipole 2. For the hydrogen bonding, for hydrogen bonding we have to say that they have that FON or not. The first one has no any fluorine, oxygen, nitrogen. Second one, third one, fourth one, the four of them all not have any of the hydrogen bonding in it. So this means they don't have any hydrogen bonding. Sometimes the students can ask that they have the hydrogen in it, but they have the hydrogen in it, which is true, but they don't have hydrogen connected to any of that FON, which is fluorine, oxygen, nitrogen. If they connected to any of them, then we can say that this is the hydrogen bonding in that case. But we don't have hydrogen bonding in that case. So last thing, as I told you, the boiling point is also calculated by the electrons they have. If they have the most electrons, so we can see that this is the boiling point. So we have to find the highest boiling point of which of these hydrocarbon. So we have electrons. We have to find out. So how can we find that? First one is CH4. What we can do that H, how many H we have? 4. So we have to consider the atomic number of the H. Atomic number for H is 1 and plus, and we have plus. Now carbon has atomic number of 6 and we have only 1 carbon. So when we calculate, we get 10 electrons. That's how we can find all of these. So 6 into 1 is 6 and 2 6 is 12 and 12 plus 6 is 18. Then we have 8 and 3 plus 6 is 18. 18 plus 8 is 26. Last we have 4 multiplied by 6, 24. 24 in plus 10 we have 34. So which one has the highest boiling point? So this one. And we can, if we go upwards, we get the lowest boiling point too. So the highest boiling point we have in that case is of butane. So butane has the highest boiling point. So that's how you can find. Sometimes you get some dipole-dipole 2, sometimes you get the hydrogen bonding 2, but in that case we only have that type of thing. So that's all for this lesson, or that's all for this unit 2. We have completed this unit, and this is like a big unit of the grade 11 chemistry, but we are successfully done that unit, and now we are doing the practice questions in the next lesson. Then we are going to the second unit of this course. So learning by with EduVibe, learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions, like me in the comment section. See you in the next lesson. Till then, stay connected with EduVibe.